सी नाउ मागचे लाईट ऑन कर ना, ते सगळे मागचे इकडे पण. ओके, great. So last lecture we introduced the topic circular motion, okay, and we also discussed about the various physical quantities that we are going to use in study of circular motion. सगळ्यांना आठवत आहे काय? ऑल ऑफ यू रिमेंबर्स इट? बरं, आता यानंतर पुढचा जो पार्ट मी डिस्कस करायला घेणार आहे दॅट इज relationship between linear and angular velocity. Yesterday we discussed this relationship in scalar form. Today we are going to discuss this relationship in vector form. In vector form, this relationship is v bar equal to omega bar cross r bar. Okay, so let us see the proof of this relationship in vector form. What I will do is I will consider a particle performing circular motion along the circumference of this circle. Fine. What will be the direction of linear velocity here? Angular velocity, axial vector given by right hand rule. Correct? हे लक्षात आहे ना सगळ्यांच्या? Particle is at this position A, so this will be my radius vector. Agree with this? And my linear velocity will be tangential to this circle. Agree with this? So you know that what are these three terms? या तीन टर्म्स कुठल्या कुठल्या आहेत हे तुम्हाला माहिती आहे का ऑलरेडी? बरं, कुठल्या कुठल्या टर्म्स आहेत बघा या. व्हॉट इज आर बार? रेडियस वेक्टर. करेक्ट. What is omega? Angular velocity. And what is v bar? It is linear velocity. Correct? So you already know these three terms. ह्या तीन terms तुम्हाला already माहिती आहेत. बरोबर आहे? Now, if a particle performs small angular displacement, it goes from A to B. And this angle is delta theta, the corresponding linear displacement is delta s. In vector form, what is the relationship between delta s, delta theta and r bar? This is the relationship. Delta s is delta theta cross r bar. Okay, we talked about this yesterday, correct? So what I will do is, I will divide both sides by delta t. Dividing both sides by delta t. Delta t ना दोन्ही साइडला काय केलं मी? डिवाइड केलं. And then I will take limit delta t tends to 0. Apply it on both sides. So delta s upon delta t is equal to limit delta t tends to 0 delta theta upon delta t cross r bar. Agree with this? Okay, what is this limit? Linear displacement per unit time. So this is v bar, this is omega bar, angular velocity, angular displacement per unit time cross r bar. See, this sequence is very important in vector form. I don't say r cross omega, I say omega cross r. Then only the right hand rule will be obeyed. हा रूल आठवतोय का बघा? My forefinger should indicate first vector omega bar. This is omega bar. My middle finger should indicate r bar. Okay, second vector. Omega cross r. Thumb will indicate what? The third vector. Okay, direction of their cross product or linear velocity. So हा rule इथे satisfy होतोय. So this is the correct relationship. Sequence is very important in cross product. V bar is equal to omega bar cross r bar. These three vectors are mutually perpendicular to each other. V bar is tangential, omega bar is axial. V bar is in the plane of circle, omega is perpendicular to plane of circle, r bar is along the radius also in the plane of circle. आणि tangent आणि radius एकमेकांना कशा असतात? परपेंडिक्युलर. सो तिघही एकमेकांना कसे आहेत? परपेंडिक्युलर. बरोबर आहे? दे ऑल आर परपेंडिक्युलर टू ईच अदर. गॉट दिस? ठीक आहे. सो राइट डाउन इन योर नोटबुक क्वेश्चन. शो दैट V bar equal to omega bar cross R bar. Show that V bar equal to omega bar cross R bar. ठीक है? V bar equal to omega bar cross R bar. ठीक है? बरं. सो घरून हे एक्सप्रेशन उद्याच्या लेक्चरला येताना लिहून आणायचं. ओके. नाउ टुडे वी आर गोइंग टू इंट्रोड्यूस one of the very important concept from this chapter called as uniform circular motion. Uniform circular motion. Henceforth it will be called as UCM. Uniform circular motion or UCM. See, what is uniform circular motion? If a particle is performing circular motion with constant speed, if particle is performing circular motion with constant speed, it is called as uniform circular motion. It is called as what? Uniform circular motion. So it is motion of particle along circumference of circle with constant linear speed is called as what? Uniform circular motion. See, when this fan is rotating, I said that every particle of fan is performing what? Circular motion. What do you think about the speed of the particle? Will it be changing? As long as fan is running with constant angular velocity, the linear speed of particle will not change with time. So that particle is performing what? Uniform circular motion. When electrons are revolving around the nucleus, they are performing what? Uniform circular motion. UCM. Correct? If you see a second hand of a clock, तुमच्या घड्याळाचा सेकंड काटा बघितला, बरोबर आहे? त्या सेकंड काट्याचं टोक बघितलं, टिप. It is performing what? Circular motion, and its speed is neither increasing nor decreasing, so it is also uniform circular motion. Observe that I am using the word speed, I am not using the word velocity. I am saying speed is constant, I am not saying velocity is constant. Why? Because even when particle is performing UCM, even though the speed is constant, the magnitude of velocity is constant, but the direction will keep on changing. When particle is at A, this will be the direction of velocity. Agree? Let me call it as VA. When particle is at B, this will be direction of velocity, always tangential to circle. Magnitude of velocity will remain constant, but the direction will keep on changing. Direction constant आहे का आमच्या velocityचं? नाही. So am I saying velocity is constant? No, I am saying speed is constant. Now we have seen that the relationship between V omega and R. What is the relationship? V is equal to R omega or omega R in scalar form, correct? So if magnitude of velocity remains constant, R is anyway constant, omega should also remain constant. Angular velocity should also remain constant. So uniform circular motion is a circular motion with constant angular velocity in magnitude as well as direction. The angular velocity will remain constant in magnitude as well as direction. पार्टिकल सर्कल मध्ये फिरतो, अँग्युलर वेलॉसिटीची दिशा बदलते का? नाही, ते ॲक्सियल असते. मॅग्निट्यूड पण नाही बदलत आणि डायरेक्शन पण. व्हॉट अबाउट लिनियर वेलॉसिटी? magnitude of linear velocity is constant. Omega is constant in magnitude as well as direction. Linear velocity ची magnitude constant आहे, direction नाही. Magnitude of linear velocity is constant. Agree with this? बरोबर आहे. याच्यावरती आता अनेक MCQ तयार होतात. Suppose particle is performing UCM, uniform circular motion. Okay. I will ask you whether the different quantities will remain constant in magnitude, direction, both. Okay, I will start with first quantity, linear velocity. What you will say? When particle performs UCM, linear velocity remains constant in magnitude but changes in direction. Angular velocity remains constant in magnitude as well as direction. Okay. Linear momentum. Linear momentum. What is linear momentum? Linear momentum is mass into linear velocity. It's a vector quantity. So V is constant in magnitude but changing in direction. M is anyway constant. So what can be said about linear momentum? Constant in magnitude but changes in direction. Linear momentum will remain constant in magnitude but changes in direction. Okay. What can be said about kinetic energy of particle? Same in magnitude and changes in direction. Now kinetic energy has direction. Kinetic energy is a scalar quantity, my dear friend. Energy is a scalar quantity. त्याला direction नसतेच. So kinetic energy remains constant. नुसतं असं म्हटलं velocity remains constant. Wrong. Velocity constant कुठे राहते? Okay, magnitude remains constant but direction changes. So velocity changes. Linear momentum changes. Angular velocity remains constant. Kinetic energy remains constant. कळतंय सगळ्यांना? What will be the value of alpha in UCM? Think and tell me. Alpha is what? Angular acceleration. What is angular acceleration? It is rate of change of angular velocity with respect to time, but if omega is constant, its derivative will be 0. Constant? 0. Its derivative will be 0. Angular velocity बदलतच नाहीये. मग angular acceleration आहे का इथे? So in uniform circular motion, there will be no angular acceleration. There will be no angular acceleration. What about linear acceleration? What about linear acceleration in UCM? You tell me. What is linear acceleration? ओके, लिनियर एक्सिलरेशन काय प्रकार आहे ते सांगा आधी. रेट ऑफ चेंज ऑफ लिनियर वेलॉसिटी विथ रिस्पेक्ट टू टाइम. व्हाट कैन यू से अबाउट लिनियर एक्सिलरेशन? इज इट 0? Not 0, because here velocity is not constant. Velocity is a vector quantity. बरोबर आहे? वेलॉसिटी वेक्टर क्वांटिटी आहे. तिची मॅग्निट्यूड जरी कॉन्स्टंट असली, डायरेक्शन काय होते? बदलते. म्हणजे या ठिकाणी लिनियर एक्सिलरेशन असेल. किती असेल? दॅट इज गोइंग टू बी अवर नेक्स्ट पार्ट ऑफ डिस्कशन. ओके, ते आपण आता लगेच थोड्या वेळाने डिस्कस करणार आहोत. आता फक्त मला एवढंच सांगायचंय, UCM is accelerated motion. UCM is what? Accelerated motion. Which acceleration? Linear acceleration is there. No angular acceleration, but there is linear acceleration. Velocity is changing with time. Agree or not? Velocity is changing with time. There is acceleration. And you know that in order to produce linear acceleration, force must be acting on body. Newton's law, what it says? In order to produce acceleration in a body of mass m, there has to be a force acting, external force acting, F equal to m into A. Agree with this? So, for body to perform UCM, uniform circular motion, there must be force acting on body. There must be acceleration. लक्षात घ्या, अतिशय महत्वाचा पॉइंट आहे. UCM जर बॉडीला परफॉर्म करायचं असेल तर बॉडी ॲक्सिलरेटेड मोशन मध्ये आहे. बरोबर आहे ना? कॉन्स्टंटली बॉडीची डायरेक्शन चेंज होते वेलॉसिटीची. बरोबर आहे का? Direction of velocity is constantly changing. So there has to be a force which is responsible for this change in direction. Can direction of velocity change without any force? No. In order to increase the magnitude of velocity, we require force. In order to decrease the magnitude of velocity, we require force. In order to change the direction of velocity, we require force. In general, in order that body performs UCM, there must be some force acting on a body. Okay, body must have some acceleration. How much is that acceleration and how much should be the force acting, that we are going to discuss. But have you understood what is UCM? Okay. One more thing regarding UCM. UCM is a periodic motion. Now tell me, what is the meaning of word periodic? Have you heard about this word periodic? What is periodic? Something that changes after fixed interval. Something that repeats, not changes, repeats after fixed interval is called as periodic. For example, you learn periodic table in chemistry. Okay, the properties of element repeats after fixed interval. Okay, and then the elements are arranged in a periodic table. Okay. Days in a week are periodic. Okay, after Monday there will be Monday after 7 days. Okay, that is also periodic. What is periodic motion? The motion that repeats after a fixed interval of time is called as periodic. Now see, when particle performs UCM, the speed remains constant, correct? So if particle starts from position A, it will come to position A after fixed time. Why after fixed time? How much time it will take to come back to position A? How much distance it is traveling? 2 pi r. If v is the speed of particle, how much time it will take? 2 pi r by v. R is what? Radius, constant. V is what? Speed, constant. So this ratio will also be constant. Correct? For completing each circle, particle will take same time. Do you agree with this? So can we call this as a periodic motion? Yes. Uniform circular motion is a periodic motion. He periodic motion आहे. The time taken to complete one circle is called as time period of this periodic motion. For particle performing UCM, time required to complete one circle is called as what? Time period. काय म्हणतात त्याला? Time period. Time required to complete one circle is called as time period. What will be the formula for time period? 2 pi r by v. Further, v is also r omega. So if I cancel rr, I can also write the formula as 2 pi upon omega. This is also the formula for time period of UCM. 2 pi divided by omega किंवा 2 pi r by v. What should be the unit, SI unit of time period? Second, it's a time required to complete one circle. So what will be the unit? Second will be the unit for time period. Can you tell me time periods of some simple motions? Earth revolving around the sun. Okay, let us assume that the orbit is roughly circular, not exactly circular, but let us assume that it is roughly circular. Earth revolving around the sun. What is the time period? 365 days. How much time Earth takes to complete one revolution around the sun? 1 year or 365 days. Minute hand of your clock. It is performing rotational motion. Each particle is performing circular motion. What is the time period? 60 minute hand of your clock. एक कंप्लीट रोटेशन 60 सेकंदामध्ये, म्हणजे एका मिनिटात तो असा फिरून येतो. मिनिट हँड 60 मिनिट्स मध्ये मिनिट हँड काय करतो? एक कंप्लीट रोटेशन करतो. ऍग्री? कोणाचा मिनिट काटा वेगळं करतो का? सगळ्यांचा असंच करतो. व्हेरी गुड. बर, व्हॉट इज द टाइम पिरियड ऑफ सेकंड हँड? नाव इट इज 60 सेकंड्स. बरोबर आहे. एक मिनिटामध्ये तो सेकंड काटा पूर्ण सर्कल फिरतो. सो व्हॉट इज द टाइम पिरियड? 60 सेकंड्स. अर्थ रिव्हॉल्विंग राउंड इट सेल्फ 24 आवर्स. ओके. आणि शेवटी आपण पण ना, आपण पृथ्वीवर आहोत, मग आपणही फिरतोय. सो वी रिव्हॉल्विंग राउंड द सेंटर ऑफ अर्थ. व्हॉट इज आवर टाइम पिरियड? 24 आवर्स. करेक्ट. वी रिव्हॉल्विंग राउंड द सन 365 days. Agree with this? Okay. Our hand of a clock, तास काटा 24 hours? No, 12 hours. Okay. नॉर्मल घड्याळ वापरत असाल 12 hours. Correct. How much time that our hand will take to complete one rotation? 12 hours. So in short, UCM is a periodic motion and its time period is what? Time required to complete one revolution. Okay, write down this quickly in your notebook. Okay, first of all, write down this. Uniform circular motion. Uniform circular motion. Or UCM. Okay, what is the definition? Motion of a particle along circumference of circle with constant speed. Motion of a particle along circumference of circle with constant speed is called as uniform circular motion. Okay, what are our observations regarding UCM? First, angular velocity, bracket मध्ये omega bar. What should I write? Remains constant. ओमेगा बार रिमेन्स कॉन्स्टंट म्हटलं की त्याच्यामध्ये मॅग्निट्यूडही आली आणि डायरेक्शनही आली. अँग्युलर वेलॉसिटी ओमेगा बार रिमेन्स कॉन्स्टंट. सेकंड पॉइंट, अँग्युलर ॲक्सिलरेशन अल्फा इक्वल टू, लाऊड अँड क्लिअर, 0. अँग्युलर ॲक्सिलरेशन अल्फा इज इक्वल टू 0. व्हेरी गुड. थर्ड, लिनियर वेलॉसिटी ब्रॅकेट मध्ये V बार remains constant in magnitude, correct, and changes in direction. Remains constant in magnitude and changes in direction. Next, UCM is accelerated motion. UCM is accelerated motion. Means what? Linear acceleration is not 0. Correct? Linear acceleration is not 0. There is a linear acceleration. ठीक है? Next point. Linear momentum, ब्रॅकेट मध्ये P बार इक्वल टू mv बार. P बार इक्वल टू mv बार. What you will write? Remains constant in magnitude but changes in direction. Next, kinetic energy. Okay, it will be easy. What you will write? Kinetic energy remains constant. It's a scalar quantity, okay, has nothing to do with direction. So kinetic energy remains constant. Next, it is a periodic motion. It is a periodic motion. ठीक है. सो आता आपण डेफिनेशन लिहिणार आहोत. डेफिनेशन ऑफ टाइम पीरियड of UCM. Definition of time period of UCM. What is the definition of time period of UCM? Time taken by particle performing UCM to complete one revolution. Time taken by particle performing UCM to complete one revolution. What is the formula? 2 pi by omega or 2 pi r by v. हे दोन्ही फॉर्म्युले सेमच आहेत. एक सर्कल मध्ये अँग्युलर डिस्प्लेसमेंट किती होते रे? व्हेन पार्टिकल मूव्स इन वन सर्कल, रेडियस वेक्टर किती रोटेशन करतो? 360 डिग्री, म्हणजेच 2 पाय. If omega is angular velocity, how much time it will take? 2 pi by omega. So this is time period. Okay, it can also be 2 pi r by v. How much distance it travels? 2 pi r by, okay, 2 pi r is a distance upon speed is v. So how much time it will take? 2 pi r by v. What is displacement of particle in one circle? When particle completes one circle, what is the linear displacement? Angular displacement is 2 pi. What is linear displacement? 0. Why 0? Because the initial and final position are same. So linear displacement is 0. So what is average velocity in one rotation? What is average velocity? What is average velocity म्हणजे काय? Total displacement per unit time. What is displacement? 0. So what will be average velocity? 0. In one rotation, average velocity is 0. हे सगळे MCQs आहेत. ओके, म्हणजे स्टुडंट्स किंवा तुमचे पॅरेंट्स पण मला विचारतात कंटिन्युअस की तुमच्या डोक्यात असेल आपण सीईटी प्रिपरेशन कधी करणार. ओके, हे जे पॅरलल मध्ये चालू आहे, आपण MCQ सोडवणार वगैरे वगैरे त्या गोष्टी आहेतच, पण लेक्चर मध्ये हे जे पुस्तकात न लिहिलेले फाईन पॉइंट्स आहेत ते मी सांगतोय. हे म्हणजे काय आहेत? हे सगळे MCQ आहेत. ओके, व्हॉट इज द ॲव्हरेज वेलॉसिटी इन वन रोटेशन ऑफ UCM? आन्सर इज 0. कळाले सगळ्यांना? बर, हे लिहिलं. टाइम पिरियड डेफिनेशन फॉर्म्युले. SI युनिट सेकंड. Okay, what is SI unit of time period? Second. Bar. Next line. Frequency. Second physical quantity is frequency. Frequency means number of revolutions per second. What is frequency? Number of revolutions per second. When a particle performs UCM, how many revolutions it makes in 1 second is called as frequency. It is reciprocal of time period. Frequency is simply reciprocal of time period. n न दाखवणार आपण इथून पुढे. साधी गोष्ट आहे, एका रिव्होल्यूशनला किती वेळ लागतो? t. एका सेकंदात किती रिव्होल्यूशन होतील? 1/t. So what is frequency? Reciprocal of time period. What will be the SI unit? Per second किंवा second inverse, which is called as hertz. Okay, hertz is a scientist, that's why capital H. Okay, short form लिहिलाय मी त्याचा फ्रिक्वेन्सीच्या युनिटचा. काय युनिट आहे फ्रिक्वेन्सीचं? hertz. Getting it? So write down this quickly. Frequency of UCM frequency of UCM, number of revolutions completed by particle performing UCM in 1 second is called as frequency. Number of revolutions performed by particle performing UCM in 1 second is called as frequency of UCM. So n is simply 1 by T. Okay, SI unit, second inverse per second किंवा also called as hertz. Many time you will find frequency mentioned in RPM. Okay, बऱ्याच वेळेस frequency RPM या युनिट मध्ये दिलेली असेल. RPM stands for revolutions per minute. So if I say frequency of this fan is 120 RPM, अर्थ काय होतो याचा? 120 revolutions per minute. So frequency hertz मध्ये कशी काढणार आपण? एका मिनिटात 120 रिव्होल्यूशन्स, एका सेकंदात किती होतील? डिवाइडेड बाय व्हॉट? 60. सो हाऊ मेनी रिव्होल्यूशन्स पार्टिकल विल कंप्लीट पर सेकंड? 2 रिव्होल्यूशन्स. सो व्हॉट विल बी द फ्रिक्वेन्सी? 2 हर्ट्ज. ठीक आहे, लिहून घ्या. आरपीएम और रिव्होल्यूशन्स पर मिनिट. ठीक आहे, आता तुम्ही वहीत काय काय लिहिलंय एक 2 मिनिटांमध्ये क्विकली वाचा सगळ्यांनी. दिस बरं, इथपर्यंतच्या पार्टमध्ये काही डाऊट आहे? कोणाला काही शंका आहे? कळालं इथपर्यंत सगळं? ठीक आहे, आपण एक सिंपल न्यूमेरिकल यावरती सॉल्व करू आणि मग पुढे जाऊ. प्रॉब्लेम घ्या एक. ब्लेड ऑफ अ फॅन has a length of 50 centimeter. Blade of fan has length of 50 centimeter and it is rotating with 180 RPM. It is rotating with 180 RPM. Find time period ठीक है. Second, angular velocity ठीक है. आणि थर्ड, लिनियर वेलॉसिटी ऑफ टिप. लिनियर वेलॉसिटी ऑफ टिप ऑफ ब्लेड. तर ब्लेडचं जे टोक आहे त्याची लिनियर वेलॉसिटी. 3 क्वेश्चन्स आर देअर. ठीक आहे. सो रीड द क्वेश्चन केअरफुली फर्स्ट ऑफ ऑल. 180 RPM is given. Okay, let me show this by capital N. 180 RPM. Small n RPS, frequency in hertz. कसं काढायचं ते? Divide it by 60. How many revolutions it will make? 3 revolutions it will make per second. So what is the frequency? 3 hertz. बरोबर आहे? बरं. What is the first question now? टाइम पिरियड. बरोबर आहे. कसा काढणार टाइम पिरियड? मग मी आता इट्स अ रेसिप्रोकल ऑफ फ्रिक्वेन्सी. फ्रिक्वेन्सी इज रेसिप्रोकल ऑफ टाइम पिरियड. टाइम पिरियड इज रेसिप्रोकल ऑफ फ्रिक्वेन्सी. सो व्हॉट इज टाइम पिरियड? 1/3 0.3333. डोंट फॉरगेट युनिट सेकंद. काय युनिट असेल? सेकंद. ठीक आहे. सो न्यूमेरिकल प्रॉब्लेम क्वेश्चनचं आन्सर आलं की तिथे असं रेक्टँगल करत जा. सो एक्झामिनर ते आन्सर चेक करायला त्याला सोपं जाईल. पुढे काय विचारलंय? अँग्युलर वेलॉसिटी ओमेगा. आता बघा 2 मिनिट समोर लक्ष द्या. टाइम पिरियडचा हा फॉर्म्युला आहे 2 पाय अपॉन ओमेगा. मग ओमेगा इक्वल टू व्हॉट? 2 पाय अपॉन टी. 1 बाय टी कॅन ऑल्सो बी रिटन ॲज एन. सो वी कॅन ऑल्सो राईट ओमेगा ॲज 2 पाय एन. हा खूप महत्वाचा फॉर्म्युला आहे, खूप वेळेस आपल्याला वापरायला लागेल. ओके, ओमेगा इक्वल टू व्हॉट? 2 पाय एन. ठीक आहे, बरं करा बरं सॉल्व. मग आता एन वी हॅव फाउंड आउट 18. ओके, टू pi n. So what is pi? 3.14. n is 3. So it is coming as 18.84 radian per second. Don't forget the units. ओके, तुम्ही सगळं करताय आणि युनिट लिहित नाही, मग त्याला उपयोग नाही. 18.84 रेडियन पर सेकंड. दिस इज अँग्युलर वेलॉसिटी. करेक्ट, व्हेरी इझी. व्हॉट इज द फायनल क्वेश्चन? लिनियर वेलॉसिटी ऑफ टिप. ओके, हे ब्लेड फिरतंय बरोबर आहे. सो हा जो टिप आहे ते काय करतंय? सर्क्युलर मोशन. रेडियस काय त्या सर्क्युलर मोशनची? इक्वल टू लेंथ ऑफ द ब्लेड. करेक्ट. सो व्हॉट इज दॅट? 50 सेंटीमीटर. So what is the formula for linear velocity? V equal to R into omega. Very simple formula. What is V? R omega. Okay, बऱ्याच वेळेस करतोय ना आपण हा फॉर्म्युला. So R 50 centimeter, 50 meter, sorry 0.50 meter, 18.84. So ये काय येईल रे? 9.42 meter per second. This will be my linear velocity. काय linear velocity? 9.42 meter per second. असं झालंय सगळ्यांचं? Got this? One more question and we'll stop today's lecture. Last question. Unit द्या. Find the linear velocity of tip of a second hand. Find linear velocity of tip of a second hand of a clock if length of second hand is 10 centimeter. बस एवढंच दिलंय. सेकंड हँडची लेंथ दिली आहे. सो दॅट विल बी द रेडियस. तो टिप जी सर्क्युलर मोशन परफॉर्म करेल त्या सर्क्युलर मोशनची रेडियस किती असेल? 10 सेंटीमीटर. बर, सो यू हॅव टू फाइंड V. बाकी काही दिलेलं नाहीये. व्हॉट इज द फॉर्म्युला फॉर V? R ओमेगा. R दिलाय, ओमेगा काढायला लागेल. कसा? आपल्याला अजून एक गोष्ट माहिती आहे. काय माहिती आहे? कॅपिटल T टाइम पिरियड सेकंड हँड ऑफ अ क्लॉक. मगाशी बोललो ना आपण, काय असतो टाइम पिरियड? सेकंड हँड ऑफ अ क्लॉक आहे म्हटल्यावरती टाइम पिरियड विल बी 60 seconds. हाऊ मच टाइम इट विल टेक टू कंप्लीट वन रिव्होल्यूशन? 60 seconds. सो दिस इज टाइम पिरियड. यावरनं ओमेगा काढता येईल. T is 2 pi upon omega. Omega is 2 pi upon T. बरोबर आहे. सिम्प्लिफाय करायचं असेल तर 3 1 3. Correct? This is what? Angular velocity of the second hand of a clock. Correct? Okay, now can you find linear velocity then? What is the formula for linear velocity? R into omega. V equal to what? R into omega. So what is R? 10 centimeter. So 0.1 meter. Okay, किंवा असं लिहा 10 centi means 10 raised to minus 2. What is omega? ठीक आहे. सो काय येईल सांगा मग हे 0.01046 किंवा 1.046 into 10 raised to minus 2 meter per second. This will be the speed of tip of second hand of a clock. करता येईल सगळ्यांना आता. Getting this? Okay, so I will give one question for homework and then we will stop here. एक क्वेश्चन घ्या होमवर्कला आणि थांबवू मग आपण. क्वेश्चन असा आहे, फाइंड द लिनियर स्पीड ऑफ find linear speed of yourself, find linear speed of yourself due to rotation of earth round itself, rotation of earth round itself, if radius of earth is 6,400 kilometer. 6,400 kilometer. This is radius of earth. Okay. Okay. I hope तुम्हाला क्वेश्चन समजतोय हा. स्वतः अटेम्प्ट करा, ट्राय करा. ओके, इथे थांबवा.